Hello learners. Now let us see how to find the integral of e power x into sine bx plus c dx. For that, I'm going to take this given integral as I. Okay, I'm going to take this given integral as I. Now, if you'll observe my next step, I wrote it as e power x into d by dx of minus cos of bx plus by b. Now, why did I do like this? Okay, because I'm going to use the formula integral u dv is equal to uv minus integral VDU. For that, I want, within my integral to be something of the form integral of a function into derivative of some other function. Okay. Now, how did I get this minus cos of bx plus b by b? Very simple. Just integrate sine of bx plus. We'll just integrate sine of bx plus. If you were to just integrate this, integral sine of bx plus c dx. What would this be equal to? What is integration of sin x? It is minus cos x, right? So this will be minus cos bx plus c. Now, divided by derivative of bx plus c, divided by derivative of bx plus c. Okay, because of chain rule, right? So this would be nothing but minus cos bx plus c divided by what will be derivative of bx plus c? There will be just b. So that's why I have this. This I just got it and kept it in this bracket. So in case if you are finding difficult, you can just integrate the sine of bx plus c and then write it like this: d by dx of this. Okay. Now next, let's continue. Now, as I mentioned, integral u dv is nothing but uv minus integral v du. So integral u into dv. So u is nothing but e power ax here, and dv is nothing but here v is nothing but minus cos of bx plus c by b. As you can see, it is d of something, like derivative of something. That's why I can say that v is this minus cos of bx plus c by b. This is nothing but u into v. So that's why you have the first term like this: e power ax into minus cos of bx plus c by b minus integral v du minus integral of v, as I kept this v as it is, into du is derivative of e power ax dx. Fine. Now next, this would be nothing but just multiply this e power x here. So this you have like this minus e power x into cos of bx plus c by b. This minus you can bring it outside. Okay, minus of minus will be plus cos of bx plus c by b. Now what is derivative of e power x? Derivative of e power x is e power x into a. Okay, again the chain rule has come here. Now next, what I'm going to do is I'm going to bring this a and b outside. Okay, so this will be a by b into this integral. Okay, that's it, no other change. Now if you'll see, again I have something of the form integral e power x into cos of bx plus c. Now I want to apply the by parts method here. For that I need to get rid of the form integral a function into derivative of another function. So for that I'm going to write it as something like this: integral e power x into d by dx of sine bx plus c by b. Again, wondering how I got it? Again, just integrate this second function. Integral cos bx plus c dx. What is the integration of cos x like generally? It is sin x, right? So this would be nothing but sine of bx plus c, again divided by, it's not just sin x, it is sine of bx plus c. So divided by derivative of bx plus c. So that's why I have sine of bx plus c by b. Fine. I hope this helps it. So that's why you can just write d by dx of this. After you just integrate this and whatever you get, put it as d by dx, put it like here, d by dx of this. Now next, now if I'll apply by parts here, here my u is going to be e power x and b is going to be sine bx plus c. The same formula which I showed you here, just apply it again. So I'd get a by b into this. Okay, now observe I kept the constant here because after this I won't be integrating anymore. Okay, I won't have to apply by parts rule anymore. So that's why I just brought the integration constant here. This is what is given in the textbook as well. Now next, as I mentioned, uv minus integral v into du. Okay, now next, if we keep going ahead, just multiply. Okay, just multiply. So you get a into like a by b into 1 by b. So this would be a by b square into e power x sine bx plus c, minus a by b square into integral sine bx plus c into what is derivative of e power x? It is e power x into derivative of ax, which would be nothing but a. So e power x into a dx plus c1, the constant which I brought. Now next, this would be now next, just in this term, this a is there, right? Just bring it here. Multiply a with a. So this would be minus a square by b square into e power x sine bx plus c dx. Now, if you'll remember, I took this one integral e power x sine bx plus c dx as I. So this entire thing, integral e power x into sine bx plus c dx, this will become my I. And meanwhile, what I did is here I multiplied and divided by b because I want the denominator to be b square, so that I can take LCM like this, and you would get what I am seeing here. Okay, since here the denominators are same, you can add it. Fine. So yes, as I mentioned, the integration I would not integrate again. That's why I brought a constant at this step. That's why this would become I, because of which I won't have to integrate again. Now this minus a square by b square into I, take it to the LHS. Okay, take it to the LHS. And in the meanwhile, in the RHS, what you can do is take e power ax common. Okay, take e power ax common. If you will take e power ax common, here a sine bx plus c would come minus b cos bx plus c, and this is how it would appear. And likewise, I want my denominator to be b square for this also, c1 in the c1 term also. That's why I'm multiplying and dividing by b square. Okay, now here take I common in these two terms. Okay, so I'll take I common, I'll get I into 1 plus a square b square. And again, if you'll see in these two terms, the denominator is now matched. So I can perform addition normally, plus c1 b square by b square. Now you'll understand why I did it. Now if I'll take LCM, I'll get I into this b square would come here. So b square plus a square, or a square plus b square, anything's fine. So I into a square plus b square is nothing but the RHS would remain the same. I did not do. Now if you'll observe, this b square and b square would get cancelled. So I'd be left out with I times a square plus b square is this, just the numerator is left out, the denominator got cancelled. And then now send this a square plus b square here. So I'd be getting something like this. Okay, nothing much, just I sent a square plus b square here. Now split the denominator to both the terms, like take this e power x into a sine bx plus c minus b cos bx plus c as one term, and c1 b square as another term, and split the denominator likewise, like so you would get what I'm showing here. And then this one I'm going to take it as some c2. Okay, because in general, whenever we integrate, okay, we are left with something like c, like plus c, but here I cannot see c, cannot take c, because it's like c is already used in the question, so I'm going to take c2. So hence my final answer would be this, e power x into a sine bx plus c minus b cos bx plus c divided by a square plus b square plus c2, where c2 is nothing but c1 b square by a b square. Okay, thank you very much for staying with me until this. If you like this video, please hit the like button, and if this is your first time coming across to my channel, please do subscribe to my channel.